Welcome back to Max with RP. We will continue to solve more problems based on either the basic proportionality theorem or its converse. Now look at the given figure. Now what do you observe? The adjoining figure DE is parallel to AC. So DE is parallel to AC. Okay. So you are given DE is parallel to AC and DF is parallel to AE. You have to prove BF by FE is equal to BE by EC. Okay. Now, let us consider the triangle. Now, what is the first thing you are given? Let us see how to prove this. First statement that you are given is DE is parallel to AC. DE is parallel to AC. So, that means what? BD by DA will be equal to BD by DA because DE is parallel to AC. BD by DA will be equal to BE by AC. So we are applying because DE is parallel to AC. You are considering triangle ABC. Okay. This is parallel to this. Therefore, BE by EC is equal to BD by DA. BD by DA equal to BE by AC. That's what I have written. This follows from the fact that DE is parallel to AC. Now, DF is parallel to AE. Which is DF here? Now, this is DF. DF is parallel to AE. So, for that also again, so look at this triangle ABE. Consider triangle ABE. Okay. Now, in that triangle ABE, you have DF parallel to AE. So, what will be BD by DA? BD by DA by basic proportionality theorem, BD by DA will be equal to BF by FE. So, we are applying the basic proportionality theorem twice in two different triangles. The first triangle is triangle ABC. So, DE is parallel to AC. Okay. So, you get BD by DA is equal to BE by EC. Next, we are considering triangle ABE. Now, this is parallel to this. Therefore, BF by FE is equal to BD by DA. So, BD by DA is there occurring on the left hand side of both 1 and 2. So, from 1 and 2, okay, what do we get from 1 and 2? The left hand sides are equal. Therefore, the right hand sides must be the same. So, BE by EC is equal to BF by FE. BE by EC is equal to BF by EC. This is what we wanted to prove. So, we have proved. We understand it's a simple application of BPT in the given triangles according to the given information. So, use the given information to prove whatever statement you are required to prove. Now, look at the next problem. So, in the adjoining figure, what is given? DE is parallel to AC. So you are given DE is parallel to AC. Okay. So if I look at this triangle, so which triangle I can consider now? Consider triangle which triangle? BAC. In that, DE is parallel to AC. So by BPT, what will you get? BD by DA is equal to BE by AC. This is by BPT. Now what else is given? This is also given. So DE is parallel to AC and you are given BE by EC is equal to BC by CP. Okay. So by BPT we have got this. BE by EC is equal to BC by CP given. So combining 1 and 2, we'll call this as 2. So 1 and 2 again you look at it, this A equal to B, B equal to C. So BD by DA equal to BE by EC, but BE by EC is equal to BC by CP. Therefore, BD by DA is equal to BC by CP. BD by DA is equal to BC by CP. That is what we wanted to prove. What we wanted to prove? How does this prove that DC is parallel to AB? If BD by DA is equal to BC by CP, then what can you say? By converse of BPT. By converse of basic proportionality theorem, the sides are proportional, the line must be parallel. DC is parallel to AP. Now we have proved the required result. So this is given to us. This is what we have to, what is it that you need to prove? To prove DC is parallel to AP. This is what we needed to prove. These two facts are given. Two facts are given. And this is something that you need to prove. Because DE is parallel to AC, I am applying BPT for triangle BAC and I got this result. BD by DA equal to BD by DA is equal to BE by EC. We are considering triangle BAC. BAC, this triangle. But what is given? BE by EC is BC by CP. So from 1 and 2 it follows that BD by DA is actually equal to BC by CP. If two sides are proportional, then that line which joins them, D and C, so DC should be parallel to AP. This is P. DC should be parallel to AP. Is it clear? Are you able to follow? Now in the adjoining figure, P is a point on the side QC of triangle ABC such that MP is parallel. So what is given? MP is parallel to AB and NP is parallel to AC. What is it that you need to prove? You have to prove PQ square is equal to QB into QC. So this is what is given and this is what you have to prove. This is the figure. Now, what is the first thing we have? MP is parallel to AB. So, which is MP here? MP is parallel to AB. That means it is parallel to NB. Correct? MP is parallel to AB implies MP is parallel to this portion of the line BN. It's parallel to BA. Therefore, it is parallel to BN. Okay. So, now look at this triangle. Which triangle I am considering now? QPM. Because in that there only I have this side being parallel to this side. So, I can apply either BPT or results of BPT. I will get QB by QP will be equal to QB by QP will be equal to QN by QM. QN by QM. Are you able to follow? QB by Q, this follows from the results of the BPT. So, QB by QP, QB by QP is equal to QN by QM. So, because I am looking at which triangle? This triangle. Okay. Now, what else is given? NP. Okay. You are given NP is parallel to AC. NP is parallel to AC. NP is parallel to AC implies NP is parallel to MC. Therefore, QN by QM will be what? QN by QM will be equal to, look at this triangle now. Which triangle are we considering? NP, okay, is parallel to MC. So, I am considering triangle QMC. Now, QN by QM will be equal to, which is parallel? NP. Okay, so it will be parallel to, it will be equal to QP by QC. Because there are two statements given to us, right? So, MP is parallel to AB, which implies MP is parallel to NB. So, I am looking at the big triangle QMP or QPM and I am applying BPT. What will I get? QB, okay, by QP will be equal to QN by QM. That is the first fact. Now, the second fact, NP is parallel to AC. Now, NP is parallel to AC. Okay. So, that means what? QP by QC is equal to QN by QM. That's what we got. Now, here also I have QN by QM. Here also I have QN by QM. So, QB by QP is equal to QN by QM. But QN by QM is equal to QP by QC. Therefore, we get from 1 and 2. From 1 and 2. Okay, from 1 and 2, what do we get? QB by QP is equal to QP by QC. Cross multiply QB into QC equal to QP square. This is what, which is what we wanted to prove. So, two statements are given. I have applied basic proportionality theorem. In both the cases, I have combined the result, I have interpreted the result and I have got QB into QC equal to QP square. Are you all able to follow? Is it clear? Now look at this. So what is given? So always write down first what is given and what is to be proved. Given DE is parallel to AQ, DF is parallel to AR. What is it you need to prove? EF is parallel to QR. Now let's look at the proof. Now what is the first one? DE. Okay, DE is parallel to AQ. So I'm going to look only at this triangle. What is that? PAQ. In triangle PAQ, what do you have? DE parallel to AQ. So what will you get? PD by PD by DA. PD, therefore, PD by AD is equal to PD by AD is equal to PE by QE. PE by QE. Now, DF is parallel to AR. DF is parallel to AR. Now, which triangle I should consider? This triangle, that is PAR. Consider triangle PAR. So, now DF is parallel to AR. So, AD by DA equal to PD by AD. PD by AD is equal to, in this triangle, PF by FR. This is all by BPT. So PD by AD in this small triangle gives you PE by QE. Using BPT in this small triangle, that is PAR, gives you PD by AD is equal to PF by FR. So 1 and 2 imply the left hand sides are same, right? PE by QE is equal to PF by FR. PE by QE equal to PF by FR. Now look at the big triangle. Now look at triangle ABC. If two ratios are same, I can apply converse of BPT. By converse of BPT, okay, what will you get? See, you are having PE by QE is equal to PF by FR. Therefore, this line EF has to be parallel to QR. EF is parallel to QR. By converse of BPT, you have EF parallel to PR. So, I applied BPT for this triangle, this small triangle. Now, I am looking at the big triangle. I have these two ratios to be same. P by QE equal to PF by FR. That means this line which joins C and F has to be parallel to the third side, which is QR. Therefore, EF is parallel to QR. Are you able to follow this? Okay. So, we solved a few more problems now, again based on BPT and converse of BPT. Okay. I hope this has given you some kind of insight into what is basic proportionality theorem and what is its converse and in which circumstance you should apply what. Okay. Please go through these problems again and again until you are able to absorb this content with a lot of clarity. Then you practice in your notebooks. Please write down the proof on your own. Copy the question alone and write down the proofs on your own. We will do more problems in the next session. So until we meet next time, it's goodbye. I hope you are enjoying your session Max with RP. If you like the video, please do not hesitate to share it with your friends. Knowledge is to be shared. Thank you.